Hello everyone, welcome to the quick version of this question. So, I'm going to assume that you've already read it and tried it out, and then you're here just for the answers to check if you got it right. So, let's just get right into it. Line of best fit, if you did this, you're wrong. Line of best fit is supposed to go through all of the error bars. So, what they expect is for you to do something nice. Good. Nice and smooth like that. Okay, that's a bit crap at the beginning. There we go. Okay, so that's the line of best fit. You can extend it out there and there, but then it doesn't really matter. Most important thing is that it's smooth and it goes through all of the error bars. That gets you the first point. Secondly, calculate the percentage uncertainty for displacement when t equals 40. Hopefully you know that the displacement will be delta x on x times 100, and that you simply need to find the values for t equals 40. So how do we find those values? Well, we find the distance here, and if you found the distance to be, like 0.5, then you're correct. But then you also need the value of x at t equals 40, and that is this value here, which is 3.0. So what you do is you take 0.5 divided by 3 times 100, and that comes out to be about, this value comes out to be about 17%. But this comes out to be 17%, but you get a leeway between 15% to 25%. So maybe you overestimated or underestimated. That's okay, because you can still probably get the mark if you did it somewhat around that value. So you get 1 mark for knowing this value and this value, and then you get another mark for actually doing the full equation. Okay, next. The data point. Okay, so this one's a bit tricky. It shouldn't be if you know how to do it. The data point corresponding to t equals 15 has not been plotted. Plus data point. When I first did this, I was an idiot, and I thought, 15, what to do? Nice. No, but what this is testing you is, can you read the graph? Does it say t? No, it says it's t to the minus 1. So actually what you need to do is first you need to find out where do we plot it on this graph? Well, we just take the inverse of t. So we go on our calculator, we go 1 on 15, and that comes out to about here. And so you know that it's somewhere on this line, because it's not 50. You don't plot at 15 seconds, you plot at 1 over 15 seconds, because that's what the graph is. Then we need to find the actual value of t equals 15. So we go into our other graph, and we see at t equals 15, the value is 9. Okay, so then we find 9. This is how I like to plot my points. You just draw the lines, and then you find the intersect. Okay, so that means it's there. That is where t equals 15 goes. I had this question on my mock exams twice, and I got it wrong both times. Lol. So it's fine. Next, suggest the range of values for which t can be assumed to be correct. Now, it hypothesizes that x equals a on t. If this was correct, then this should be a straight line. But obviously it's not, because that's a curve. And so there's 2 answers that you can say for this. First, you can realize that, whoop-de-doo, that looks like a straight line, and you can say it's between 0 to 0.5. But then you need to remember that it's not 0.05, it's 1 over 0.05. So you go on your calculator, 0.05. So 1 over 0.05, which I think was 20. 0 to 20 seconds. But then the other option for the answer is it does not support. You say it does not support the hypothesis, because line does not go through origin. because even though that this is a straight line, it doesn't go through the origin. If it doesn't go through the origin, that means it's not proportional. Yep. Okay, and that is the answers for that question. Hope you got them right.